Good morning, or I guess afternoon, whenever you are viewing this presentation. We're Nick King and I are excited to present to you what we have done with Mississippi State and looking at and evaluating automation, and with Nick King talking about the components or the equipment that they have through Precision King in Valmont. But as we go through this, we'll have my contact at the end of this, and I'm sure Nick will have his. If you have any questions about what we've spoke about today, feel free to contact us, and we'll have a QR code at the very end of this presentation for the CEU credits. With that, Nick, go ahead and get started.
Perfect. Thank you, Drew. As Drew was saying, I'm the president of Precision King. We were recently acquired by Valmont Industries this past year, and really excited to be a part of the Valmont family. And we're going to be discussing irrigation automation in row crops or flood irrigated crops and rice today. And so, as Drew was saying, I'm going to kind of discuss what is flood irrigation automation and why is it important, what components, and then Drew's going to speak to some of the research and look field testing that they did this past year. This has been our mission statement for several years. Why is this important in farming? And we say it this way, that farming is tough work with a lot of details to manage, and that just seems to be becoming more and more true every year in the farming industry. Our goal as Precision King is to help farmers manage their water systems, allow farmers easily management so that they can use the water to save time and money. So that's our goal, is not just to be a cool new gadget, but hey, this technology has got to make the farm money. And one of the benefits is I think we're all interested in if it can save us time to have more time with our families. I'll put this slide up here. Automation is the future, but what does the future of irrigation look like? There's just lots of talk of drones and different technologies that we're going to control weeds with in the future. And, it's interesting to have conversation with growers to say, we've irrigated a similar way for the past 25, 30 years. What do you think irrigating crops is going to look like in another 5 years, 10 years, 15 years? I get a lot of different answers to that. Why should you as a farmer be interested in automation? And I went and pulled a clip out of a news article that was just posted this past month in December. And this was their headline. The global irrigation automation market size is expected to reach almost $8 billion by 2026, rising at a market growth of 22% during this period. And again, this was a news article posted this month. And I put a picture of a John Deere tractor here to say, when RTK or guidance steering came out on tractors, it took several years for the industry to adopt the new technology, and that took several years. But once it caught a hold, can you imagine farming without that now? And so again, the market is starting to see that automated irrigation is what's on the horizon and is the future of irrigation. And it's just the question is when exactly is it going to grab a hold and it be where we don't look back just like we did with RTK. Some of the experts think there's a huge adoption curve coming currently. So yeah, it's something to keep our eye on, or things are about to make a shift in our opinion. So I put a few bullet points up here on why should you be interested in automation. The number one reason always is profitability, and I think you'll hear that today. If a practice does not make the farm more profitable, at the end of the day, it's not going to get adopted very well. And so, automation brings profitability to the farm. I also put up here just efficiencies. You know, these systems you can design or create uh, irrigation well to run different sets, and once you get it programmed, it does it without anybody switching valves or it takes all the thinking out of it. So it just creates a lot of efficiencies. Conservation is always a big deal in today's climate, but very rarely do you see profitability and conservation go hand in hand. And with the automation systems, it does. We put easier management. Everybody's looking to use their labor wisely. And the last point I put on here is, not that I guess I am a perfectionist, but I always want to do the tasks that I'm responsible for to the best of my abilities. I want to give it my best, and I have found that that's almost a universal theme with farmers is they don't plant a crop just to make a C on their grade. Everybody's aiming to do their absolute best in farming, and when it comes to irrigating, I think we want to irrigate to the best of our abilities. Uh, so, what components would consist in a row crop automation system? Um, and so, I want to go through those right now. Even though we don't make the very first bullet point, computerized hole selections is a big part of flood irrigation uh, automation system. We want to make sure that we've got that pipe designed correctly, has the right holes. It kind of would not make sense to do all these other things and then not have a correctly designed hole selections for that pipe. So I stuck that one in there. The next three, we would say these three products work together in automation to achieve the efficiencies and profitability that you're looking for. The first one is we want to use soil moisture sensing technology uh, to uh, to trigger irrigations. Um, we need to not be doing that premature and be be triggering those irrigation uh, events at the proper time. Pump automation is you need that in an automated system so that you are controlling that pump and it's only running when it needs to be running. The key to this system, or the missing key, was valve automation, in that you can irrigate multiple sets in a in a in a water irrigation well. You can switch from field to field. So that's the three main products. I just put a note in here that all the products are telemetry products, meaning that they're being controlled remotely and through a server. Um, I just put a few pictures up of what some of these look like in the field. This is just your typical soil moisture telemetry unit um, in a cotton field. Uh, and I put this graph up here. This is what typical overwatering once a week looks like. You can see that the green line is our trigger point, and as we went over time watering once a week, our moisture continued to go down. A lower number means lower numbers is wet, higher numbers are dry. And so you can see we continuously on this graph over time, we irrigated about once a week, and we just kept getting wetter and wetter and wetter and wetter. And that's what we've got to try to avoid, is overwatering. And that's what soil moisture controllers help us do. Pump controllers just control the pump. And we can start, stop, schedule when we want these things to an irrigation well to come on. It's not a big complicated system. It's just a controller that goes on electric wells and diesel wells. but the one I want to focus on for the moment is valve automation. As I mentioned, this has been the missing key. You know, pump automation and soil moisture telemetry have been around for a little while, but valve automation is the thing that is the newest missing key to automated systems. And with this, it has allowed us to make programmable irrigation sets where we can say run field one for 15 hours, run field two for 6 hours, run field three for 24 hours, and it'll walk through those sets that are on that irrigation well and water them one by one. Uh, it just helps us eliminate waste, reduce labor. Um, the other big thing is surge technology has been out for a while. I know Mississippi State has done a good bit of research on that front and the benefits of that. You can um, program your sets to surge your fields as well, to get that increased efficiency out of this technology also. Um, so just real quickly, just a few pictures of what a automated valve from Precision King and Valmont looks like. It's an aluminum valve that you put in your riser or well, and it's just a part of the automated system. So that's a quick rundown through the components and some of the benefits of automation, and I'm gonna let Drew talk about what they've looked at this summer.
All right. So kind of just getting started on and some background on my mindset as I came in and into this role and looking a lot of what Nick said as well is what's the next step, where the technology's taking us. We've been irrigating a certain way for a while, and I kind of boiled my thought process down to two things for my program and where I would like to focus on is investigating new technology in furrow irrigation. Where's the technology at that exists already that we can apply and evaluate and test on farm to bring the irrigation efficiency up to the next level, and then the proven irrigation water management practices like Nick had mentioned, well, soil moisture sensors, surge irrigation, computerized hole selection, being able to utilize those and promoting those on farm through adoption, through our extension program. Everything kind of boiled down to those two things when I looked around and saw what I felt like we needed to do next. And so most of this presentation will be looking at our year one investigation into the new technology. And this is basically just restating what Nick said, but any type of irrigation management practice, whether we're talking about this new technology or things that have been shown and proven time and time again, they need to be economic, they need to be profitable. And so if it's not profitable, it's not sustainable. It's not going to be adopted. And it's not going to be used for an extended period of time. So we need to make sure that it's going to make the farmer money. And then we go into conservation, environmentally sustainable. We want to use less water. We want to preserve the resources we have, and then socially supportive. We want to increase farm families and their time with their family, their increase their quality of life. And if we can find practices that hit right in the middle of all of those, then that's our goal, and that's where we think we're headed with this is being able to hit all those sustainable, economic, social, and ecologically sound sustainability. And some just background on what has been done through Mississippi State, and really, again, Nick mentioned this as well, but the foundation of our irrigation water management and where we're at currently, and that's using computerized hole selection as the foundation before we start anywhere. Because if we're not doing that, then we really aren't irrigating correctly and even if we're using soil moisture sensors and or surge or automation, anything beyond there. So we want to start with computerized hole selection. And then so what we've done is find those tools that can be used on farm, and then we evaluated those and trying to hit with the sustainability, economically sustainable, environmentally sustainable, and socially sustainable. And so we started pushing the on-farm practices, but also some evaluation and research on farm. And so here's just a quick graph from the NAS survey that shows when Mississippi farmers are asked what are they using to irrigate, to schedule irrigation, and this is for the state of Mississippi. And you can see far more, the far majority of that is condition of crop. Um, and sometimes that can be an okay way to look at things, but a lot of times that can be misleading. And then is some of the graphs that Nick showed and some of the graphs that I'll show later, as you continue to go throughout that season, the scheduled irrigation, you can see personal calendar, feel of soil, and in probably reality, it's a combination of several things that they're looking at. But we're trying to increase the adoption of, in this particular case, when scheduling is soil moisture sensors to bring those up. And I think common issues with soil moisture sensors, and this could fall into surge automation or surge irrigation as well. But common issues we see is interpretation of that sensor data. What does it mean? What are thresholds? When do we start those triggers? What are these numbers that I'm getting mean? How do we get that data? Is there telemetry offers? Do we go out and manually take those readings? And then the cost, and then how those systems support. And so, kind of tying all that back into just really back into the foundation of things is when we're trying to promote irrigation practices and using soil moisture sensors, anything that can be made easy and take some of the guesswork or to even some the decision making, make it easier and put in front of them these platforms like precision keying can really aid in a lot of the issues that we're seeing when we're talking about scheduling with irrigation. And so here's the background information that kind of led to the next step of automation and this is where we're comparing those irrigation management practices of surge irrigation, soil moisture sensors, and computerized hole selection on farm. And you can see the maintaining or increasing yield in corn. We increase the yield, less water use, and then you increase your water use efficiency. And again, kind of going back into those three tier of sustainability, we're increasing profitability as well. So this is our corn, and this is our soybean. Water use decrease, water use efficiency increase, profitability and return on our profitability or return on investment is increasing. And so, knowing all those things these items work, soil moisture sensor works, and we're still struggling with some adoption with those. And even if they're adopted, putting a soil moisture sensor in your field is not going to save water itself. There's a whole lot of things going on farm, decision making, whether that's keeping up with the soil moisture sensor or interpreting the soil moisture sensor correctly, or just being able to physically be around to get it started, or then switching over to the next field can really use a lot more water, even though you started your scheduling based on soil moisture sensor data. And so what we wanted to do is to evaluate products that were on the market that could advance new technologies that could advance or increase water use efficiency in furrow irrigation. We wanted to evaluate those on how they functioned, or the functionality, are they working, put it through the test and put it through some on-farm sites. And then as we build up our sites and our different types of plots and comparing them across different wells, then we'll start adding in that profitability standpoint into it to put the economics and see how much based on the water and the labor, what that means from an economic standpoint. And so this was our first year as we look through our evaluation of our first year. You saw some of these pictures from Nick's as well, but the two main valves that we utilized was this two or double actuated valves where we can open and close each side on that T on your left, or the single actuated valve, open or close on your right. And Nick mentioned this as well, but kind of in our work, in our terms, or what we looked at is what is furrow irrigation automation, and we're just wanting to really tie all those, really those three components that we looked at on farm, could we tie those together and make it easier for that farmer to not only adopt them but utilize them and use them more efficiently. There's a lot of human error, but also decisions going on when we utilize those practices. And so, if we could tie those in together, decrease the errors or and time and labor to start that process, then we thought that we had something here to where we could look through that evaluation process. So we wanted to connect valves, our sensors, pump controls, and then through their, in this case, what we utilized Precision King's platform is be able to control that through an interface. So it really gave the growers the ability, and from the pump station, to start that spin from the first well or the first field to the last field remotely. And so we're looking at saving time, money, and water. Nick went through some of the components. Here's some of the pictures of our on-farm evaluation and our plots as well. Some of the double actuated valves, single actuated valves, and then again tying those to soil moisture sensors. And so, as we had the soil moisture sensor and our actuated valves and our pump controller, Nick mentioned, but they're through telemetry, so you have a one-way um, feed into our from our soil moisture sensors that are giving our soil moisture sensor readings. And then we have our valves, and that's going to tell whether it's open or closed, and we can command those to be opened or closed. And then the same thing with our pump controller. It's going to tell us whether it's on or off, and then we can program it to turn off or on based on timings. And then it's going to go into the user interface, and we can control that through our computer or our tablet or iPhone. And Nick mentioned this as well, but we can basically start our entire spin. We can set our irrigation times and based on the equipment that we have, but really through all those fields associated with that well, from the first field or first set to the last set, we can have a seamless start from the moment we say, all right, we hit our trigger to the very end. We can have that seamless transition from one set to the next and really gain a lot of time and then water use as well, we believe, as we seamlessly transition through that. So here's just an example of a scenario that we had. You had 4 sets, and then these are the times. And so if somebody's utilizing soil moisture sensors and they're irrigating correctly and triggering or scheduling correctly, even when they start, there's going to be some hiccups that we may see with that. And then someone's not going to be able to be there right at the moment to even get it started, based on what the trigger or the soil moisture sensors are telling us, and then also transitioning through to the whole field set. So as it irrigates out, we have, and we go through and we go through our spin. So if we started that at first thing in the morning at 7, and then the next day went through 11, in this case, that's not bad times. 11 a.m. We're going to go through 11 a.m. When we start getting those times where it crosses over, when we want to be in bed sleeping, is where we can make up a lot of that water, that time. And so from 3 a.m. In this case, it needed to water out and needed to be switched over at 3 a.m. And so instead of letting that run until the next morning, we gained a lot of time. And that's just one scenario, but you see quite a bit. And I know those that are irrigating the sets that are supposed to probably water out at about 11 o'clock or midnight usually don't get switched over until the next morning to make sure. So you can have that not only whether it's in the middle of the day, but through the night, we can gain a lot of efficiency through that. And so here's just some of the things that we saw with that. We had one where we kept having a lot of pressure. I don't know, from that system that we had. So we had added a blowout into that, and it worked great. Once that pressure was released through the top, and it went back down, and it started irrigating out. But through that process, this first year evaluation, we had all our valves open, closed, based on our scheduled times. As long as we had power, and so sometimes we had some rural electricity issues, but as long as we had every valve open and close and go through its spin every single time, and we had great great results from our first year. This is some of the graphs that we show from a and then this is a conversation that I have a lot, quite often on farm, and then that's the threshold versus trigger terminology. And our research is this is our threshold, and we don't want to go past this, so we don't reduce any of our yields. But the trigger is going to depend on your farm, how long it takes to get a spin, when it triggers you to turn on that irrigation well, so that you're done irrigating and that last field doesn't go past that threshold. And so I believe in automation is we can squeeze that a lot closer to where we're not worried about that last field getting stressed, because the time that it's going to take to spin around can be closed in. And so as we work through that, you can see we triggered on a or irrigated on a trigger, and we didn't come near where we needed where we wanted on our threshold. We didn't pass our threshold, which is what we want. And here's a compared field, and you can see how often their irrigation, and they didn't come close to not only a threshold or a trigger. And so utilizing information from our soil moisture sensor, but then again taking that to the next level through automation is what we're trying to evaluate here. And just similar to Nick's graph of a weekly irrigation, this was a set of sensors we had on a farmer's field when we were doing some research on, and it stayed wet throughout the entire season. And then Nick's graph showed really, even if a certain time frame in the summer where maybe a weekly irrigation is needed, as that plant, whether we have more rainfall or that plant doesn't use the same amount of water that it did in the middle of the season, while it's most productive, it starts to decrease throughout that season. And so just going off of an irrigation calendar schedule is not going to give us the irrigation timings that's the most efficient for that. And so we showed some of the background information. Here's the soybean fields. We had 3 wells with a series of fields associated with each well. So we had 3 sites, compared 3 wells where we had the producer versus the automated site. And you can see our yields, our water use, and then our water use of efficiency. And so I think that's backwards, Nick. I'm so sorry. That we use less water across the soybean and the corn, and we'll get into rice a little bit later. You can see the corn here, 226 yield, 230 automated, and then our water use was significantly lower compared to the producer field. And so this is not just comparing 40 or a 40. This is the whole series of wells, and I think this is where we're catching up a lot of the water use is from start to finish, and being able to push that trigger a little bit closer, because you may, just like you may start your irrigation set not only just because it needs the water, but because you know all the other things that you have to be getting done by that time, and if you don't start it now, you may get. And so we can just initiate that start, and it goes through that spin, and then that's where that's what we've seen with that. So we had less water use in both our soybean and our corn, and maintained our yields again this first year. And as we gain more sites, we'll start looking at the economic components of it. But everything has worked really well. And this is our row crop. We had sites, three wells on corn, 3 wells on soybean, and we'll continue to increase those compared sites.
Perfect. So we'll swap over to rice. Where did it go? There it is. Y'all wore them out on corn, Drew.
Yeah, we did. And I think it was flop, but so we had 10 acre inches. They had a little over 10 acre inches for soybean, and we had 6 acre inches for our automated side, which is a little closer. But yeah, the corn was quite a bit different.
Yeah. Um, well, I hadn't done the math, but I mean, on the corn, that's granted, I understand it's 1 year data, da 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 da, but I mean, that's 60, 70% reduction in water use. I mean,
A lot of water, a lot of.
that's a lot. Well, the soybeans easy to see. It's just the 40%. Um, all right, you ready to go for round two?
I'm ready. Jump into right.
All right. Well, we're going to switch gears a little bit and talk about rice. We, there's lots of different ways to irrigate different crops, and rice is a little bit of its own world. We don't. I don't know of another crop that we irrigate in standing water like we do rice. So, it needed some. Uh, it needs its own logic or its own uh, applications of how automated system would work with it. So we're going to walk through what are the components. The components are very similar or pretty much the same, but there there is a little bit of that you can ease into the components, and we're going to walk through that. The components will build on top of each other if a grower wants to ease into those, similar to what we did originally in row crops. One of the biggest things we pushed in the beginning was for growers to adopt a soil moisture sensor to put in their row crop, corn or bean field, so that they would know when to trigger an irrigation. And there's that same capability in rice. We call, just as a way to easily communicate to the market or growers, we would say that that's our basic offering for rice, is that a grower would buy a Rice King monitor, and that monitor, its only purpose is to monitor the depth of the water in a field. And so in the basic, you're not controlling the pump or a valve. You're just putting a device in a field that is monitoring the depth of the water. So that would be, we say this is a place to start for a grower. Um, if he's wanting to get into rice automation, or monitoring, that the correct place, in our opinion, to start is to get um, uh, a live look at what his depth of water is in his rice field. So that's our basic. Um, I will just put an example of what a graph looks and what the dashboard or the uh, interface would look like on your phone. On the left here, you can see those are different rice fields: Fish Pond East, Fish Pond South, and this was a snapshot after the growing season. But you can see that it's going to give you a depth of water. Currently, they're showing negative. This was a AWD site, so we were measuring below ground water depth. So that's why there can be a negative water depth. And if you look at the graph on the right, you can see that there's positive numbers and negative numbers. But if you look at the graph, he wanted to try to keep his water at his trigger at 1 inch. And you can see that basically every time the water dropped down to about 1 inch, he started pumping and would pump it back up. And you can see how consistent he could stay around that 1 inch mark. So just a real quick look at what the dashboard and capabilities are. Now, in farming, a lot of times we talk about low hanging fruit. What's the no brainer? Our intermediate, we call an intermediate rice field, or is a low hanging fruit to me. And I know these, probably only represent 10 to maybe 20%, 25% of the market. But if you've got a well that on a rice field that is pumping only into one field, this is a low hanging fruit. You can have the water level, the Rice King water level, and a pump control, and with no valve control because you don't need a valve because it's only pumping into one field, and you can automate that particular field. The water level and the pump unit work in a integrated system where uh, that that water level monitor is cutting the pump on and off based on what you set, what we call your high and low trigger. When that rice monitor hits its low trigger, it's going to tell the pump to come on. When it pumps that field up to its high trigger, it's going to cut the pump off. For me, this is a low hanging fruit. Um, in the rice world, uh, this isn't real expensive to get this system on this type of setup. So it's what we call our intermediate rice field. And this advanced rice field is what we're going to probably spend most of our time discussing this afternoon. This is what we would call an automated system where you got multiple components working together to manage and to seamlessly, remotely, automatically manage water levels in rice fields. So let me walk through this. So just like the others, you have monitors in each field that are looking at the water level. You have a pump control that is controlling the pump, and then you have automated valves on the risers that are opening and closing depending on the water level and which field needs pumped and which field doesn't need pumped. Uh, so we put this diagram just so people could get a look at what's required, but that is the components of an automated rice field. Uh, and with that, I'm going to turn it back over to you, Drew, and let you discuss some of your own farm trials this summer.
Pull it back up. There we go. So, yeah, that was a great lead in to what we would very similarly did in our soybean and corn fields is really utilizing this automation the same way, really the same components, with the difference being, like Nick mentioned, being the sensors. And so what we utilize with these sensors is our is these, in this case on the right you can see the panty pipe, and they have a sensor that can utilize that same pipe but send a signal back to the telemetry through the telemetry service back to our interface to give us those readings based off that. And really going into, again, starting with some of the background information that we utilize to start, at least as a foundation, to where we wanted to take the next step into that. And here's our summary data of all of our AWD rice fields with this is no automation, but just utilizing conventional multiple side inlet, and then comparing multiple side inlet with alternate wetting and drying. And so these are our results, and we consistently saw reduction in water use, especially when we saw that utilizing AWD with that side inlet, to where we would see 30 to 40% reduction, with up to, I think we ended up with about 20 farms at the end of it, to where we could see that water use reduction across that site. Again, in the right, you can see where that profitability is, and how that increased by about 30 for that compared to the conventional. When I say conventional, that's your cascading flood irrigation techniques. And so at the same time, we had some on-station comparisons, and just like Nick mentioned, that those water levels that that those sensors are able to detect and then send into those readings. We had some on-station research to look at what does it mean from a yield standpoint and a water use standpoint if we triggered off certain irrigation thresholds. And so here's just a picture of a visual of what that would look like at 0, and then what it would look like at -4 reading. And just to be able to run through it pretty quickly, this is our on-station research that was done, and you can see our continuous or our keep continuing to keep it at least +4, and then at soil surface at 0, down to -4, -8, -12, and -16. And there was no difference in rice yield if we kept it from our -4 up to our +4. And then after -4 is when we started seeing reduction in rice yield. And when we look at our water use, we saw no difference in water use at -4 through -16. But there was a difference between -4 and our continuous and our 0, our soil surface. And so what that showed is that sweet spot there that we were able to look at is if we can bring that down to -4, we're not going to we can use less water, and we're not going to reduce our yield based on our on-station research show. So which kind of leads into what an AWD management would look like, and allows you to have a drying cycle. And this is from some of the research that Dr. Massey had looked at as well with this graph, and being able to have that drying cycle out. But what we can with those sensors, we can not only know where we're at, and know what's currently the levels are being, but we can trigger off that, or we make sure we don't go past a certain threshold before we can start watering that back up. And so that just allowed us to get more comfortable with that drying out system, and then being able to schedule that irrigation. And then that automation just really led into be able to control this from it's very cut and dry whenever you can have a top cut on and cut off with our pump controls based on sensors in the field. It is really black and white if you can set those tops and bottom standards. And so
Drew, I'll just add, some of the seems challenges for a grower to adopt AWD is it's just that managing farmer or owner, it's hard for him to be everywhere, and he's having to rely on labor and training them to make some of these calls. And remote sensing on water level puts in his hands where he basically can be everywhere, knowing what all of his irrigation managers are doing, and he can get a real handle on
that's right.
where are we at? Are we at 1 inch, 0, 2 inches? And it gives them as an owner, operator, grower the confidence to adopt some of these practices.
No, I agree. I mean, and you may see this as well, but just talking with quite a few growers, and the mentality, if they utilize AWD, what they're scheduled. A lot of time it may be based on what it looks like, and that can be hard because obviously you have to go and lay eyes on that and be able to see. But then what that could look like to one person versus another can also, and like you said, the help or the labor to teach them based on what that looks like when to initiate it can get a little more difficult. And then when you have, especially with one well, and you have, like you said, your advanced example, when you have multiple fields, this also helps you make those decisions on which one you want to start first and which one needs it the most. And when they may visibly look pretty close to the same, you can be able to make those decisions off that. And here's our rice automation. So we took that information that we knew with the yields, utilizing the sensors, and just add pump automation to those sensors, and then the valve controls, and to where we could utilize that, and we set it up against some growers, and you can see this is field by field. Some of them got pretty close. The AL1 and 2. did a really good job. It's a good job irrigating rice. But really the difference in this, and they're using a lot of the same techniques that we were using, minus the automation. And so we were able to really push the limit, and know where we're at, and not only I think just pushing the limit, but feeling comfortable that we're not getting close to a threshold, which with utilizing those sensors, and then just being able to automate that. And then, just from our infield experience this first year, again, this is year one, being able to cut off a well when we start getting heavy rainfall. We know where those levee gates are. We know how much distance we have in between with those sensors, and if we feel pretty comfortable a rainfall coming, we cut off, and then we see what we saw, what we get, and then if we didn't get it filled back up, we could kick it back on. But most of the time, we were able to utilize that. And so again, we utilize cutting this off through rainfall events really frequently this year. And so this is just more of a summarized slide set of that, been able to compare our yields to the producer, accumulating or getting them all together, and then our water use comparison, and then our water use efficiency. Um, and that's our rice yield results, or our summary results, but just kind of more of a conversation. And Nick, jump in if you want to add anything to this. Just some of the things that we were able to utilize, or learn from this season. You showed it in your graph where your sensors were on the farthest end of the field, and that's one thing we made an infield or an in-season adjustment on. When we had our trigger, we would hit our trigger and cut off the well, and then that water kind of settled out. So once we moved our sensors to the as furthest away from the poly pipe, it started hitting it right where we needed to hit it. I don't believe one drop of water went over a levee gate in any of our fields, whether that was with rainfall or through irrigation. And we felt really comfortable about where we're controlling that, and whether that was the top end or the bottom end, just controlling that average amount, and keeping it wet, and not feeling like we were going to get behind, utilizing that automation. Um, we really enjoyed using this and evaluating these rice automation. Well, using the same valves, but with the with the sensors in the fields that y'all have, be able to see where the water is, and then make sure we feel comfortable with what our triggers are with that. Anything you want to add on the rice standpoint?
It might just be more of a general statement. I feel like the farming industry in almost every other sector has sought out efficiencies to the maximum level. I mean, we have precision planters planting seeds exactly 7 inches apart. We got GPS on our tractors where we're not, having narrow rows and wide rows, and so we can maximize literally every inch of the field for it to be uniform. But the one area, in my opinion, that's left on the farm that there's great efficiencies to be achieved is in irrigation. I mean, and that's what some of these results show. That there are significant efficiencies which lead to profitability to be had in irrigation, and automation is the answer to making that reproducible. Because you're just taking the variability of farm operation and amount of labor, and there's a lot of variables on how efficient a farm operation can be without automation. But it is one of the last areas on the farm that there are significant efficiencies to be gained on. So automation, in our opinion, is the answer to that. So we're excited to be a part of that revolution, if you will, and it's exciting to be working on what the future looks like.
Yeah, I second all that. It's been really enjoyable to be able to do this, and you know Dan Roach too, and he just tickled as could be to tell me he's scheduling some of his rice fields. In his words, I'm scheduling it from my lazy boy, and so we just it just opened up a whole other way to look at it and be able to schedule that irrigation. But not only just bringing it down, like I say, if we don't cross that -4. Um, but it's also that sometimes I feel like we would irrigate up to a certain point just to feel comfortable and let that so we have more time before it waters back down. And I feel like we can tighten all that together by squeezing them together when we have that automation because we feel comfortable we can get it on and off without having to go and manually turn that on and off and wear somebody out by looking at that. So even if we wanted to lower it and have more rain capture on that top end to make sure we have plenty of space, but a freeboard on our gates. I mean, just kind of opened up a whole other ways to look at things that automation I think can add to it. It's just a different way to a way to manage irrigation, and it opens up more doors than just strictly turning it on and off remotely. I believe.
I agree.
And just as we wrap up, I wanted to point some of the irrigation resources that we have at Mississippi State as we continue to develop some of these. I just wanted to close out with some pointing to some resources, and so we've started creating some extension fact sheets utilizing soil moisture sensors. So that we talked about in the first half of this presentation. Uh, One of the most popular irrigation sensor is barometer watermark series. And so one of the 6 areas that we felt like we wanted to start attacking, and some of the questions that we can commonly get is, that's irrigation. I mentioned those triggers, how we're triggering our irrigation, if they want construction, location, installation, telemetry devices, including Precision Kings and others, how you take those measurements, and then the background of watermarks. And so the three highlighted is what we currently have posted on Mississippi State Extension's website, and where we are working towards in the near future those other three that will be coming out. Another thing that we have is our soil moisture sensor showcase that Precision King was a part of, amongst other companies as well. But one of the most popular question I probably get on farm would be, what type of sensor do I use? And a lot of times what they're saying is not what sensor, but what type of telemetry service. And so what I wanted to be able to show them, and what we did as an extension team, irrigation team, was want to be able to show them is be able to log in and look at the different looks. Some of them are just basic numbers that we talked about, those cinebars, and some of them have interpretive graphs, and they can do the weighting for you. And there's just a large range of what offerings that each one of these have. And so what I want to be able to do is let them log in, let the grower log in, and help make some of those decisions what fits their personality or their management style, or what information they want to see the best. And so with this, and we'll hopefully continue this next year as well, we had all the sensors lined up, so you could see the actual hardware. But really, most of that learning took place, or the outreach took place, is through these logins. So a grower could utilize our logins, our username and password login to each one of these companies, log in and play around with what those sensors and those dashboards look like. And so those are, not only do they not have to go through a season, maybe with one that they didn't feel that was fit their needs, but also they didn't have to pay for anything as well. So this is a way to uh, help make those decisions when you look at soil moisture sensor packages. And here's just a look at of what that looked like out in the field. And then with that, we created a series of YouTube videos, not only about how to work through those dashboards of each company, but we're working through other things like installation, sensor removal, and things like that, just to help any type of information we can put out there, that we can. And that's at our National Center for Alluvial Aquifer Research website through Mississippi State. But with that, I just wanted to thank Nick for presenting with me today and going through this automation and then also all the promotion boards that have supported this automation evaluation and promotion of conservation practices. In addition to the promotion board, the NRCS project that we have that really is wanting us to look at new technologies in surface irrigation project that we have and be able to utilize that. So with that, Nick, do you have anything else to add?
Not that I know of. Just have enjoyed working with you guys, and it's exciting to keep thinking and imagine what the future might look like in the future.
I agree and look forward to going beyond 1 year of data sets and then continuing to build off what we have. And so as we go into the next slide, here's instructions for the certified crop advisors that you can go through with a link there and instructions with that. Also, or the other way would be utilizing that QR code there. I appreciate your time. Thanks for listening.